Hello, everybody. Welcome to Chapter 6, Chem 1115, Chemistry and Society. This is the notes lecture for Chapter 6 of the current textbooks. So in Chapter 6, we're talking about energy from combustion. So the guiding questions to get us started: what are fuels? How much energy is released do we get from them? How is electricity generated? What are some of the environmental implications for fossil fuels? What are the benefits of biofuels and sustainable energy? So this is something for you to reflect on. I'm not going to go over it because that's part of your reflection. All right, a fuel. What is a fuel? It is any solid, liquid, or gas that may be combusted, and combustion is just another word for burned. Any solid, liquid, or gas that may be burned to produce heat or work. And then fossil fuels were formed millions of years ago from decaying plant matter. So when we talk about fossil fuels, we're talking about something ancient, hence the name fossil fuels. So there are three requirements that we need in order to have a fire. You need a heat source, you need a fuel, and you need an oxidizer. So fuel plus oxidizer plus heat gives us our products. And the majority of our fuels, at least when we're talking about fuels in this class, are hydrocarbons. We'll define that in just a minute. And then most of the time, the oxidizer is oxygen gas. So you've got to have oxygen, you've got to have something to burn, and you've got to have sufficient heat. Without those three things, you don't have a fire. And likewise, if you ever want to put out a fire, just get rid of one of these things. Get rid of the oxygen, get rid of the fuel, or get rid of the heat. All right, so what is a hydrocarbon? A hydrocarbon, as the name implies, hydro, like hydrogen, carbon, like carbon. A hydrocarbon is a molecule formed only of hydrogen and carbon. So all of these are the same hydrocarbon, actually. These are all for butane, and just different ways of representing the same molecule. Molecule made completely of hydrogen and carbon. And if you go on to study organic chemistry, you'll be studying this in great detail. These are just some of the common hydrocarbons that you'll run into. You do not have to memorize this. Hydrocarbons are named based on the length of the chain. And again, that's not something for you to memorize in this class, but it is something that you would learn in future classes, especially organic chemistry. So when we combust a hydrocarbon, we are going to get carbon dioxide and water as our products if you have a complete combustion, which in this class, that's the only kind of combustion we're going to focus on. There's also what's called an incomplete combustion, but again, that's a topic for another class. This is just a survey class, so we are only focusing on complete combustion, which when you're dealing with a hydrocarbon, produces carbon dioxide and water as your products. So energy is just the ability to do work. And here's a little video that you can go watch on atomic interactions with energy. And this is a really important distinction too, heat versus temperature. So heat is just energy that goes from one substance that is hot to another object that is cold. Okay, that's what we call heat. The flow of energy from hot to cold, we call that heat. Whereas temperature is very different. Temperature is a measure of the kinetic energy of the atoms or molecules. So if you touch something that has a high temperature, that means that those particles are moving at a fast speed. And so that's why you go, ouch, that's hot, because you're feeling the transfer of that energy, that heat energy being transferred from that hot object to your finger. And temperature is a measure of the energy. And so likewise, if something is cold, the particles are moving at a much slower speed. And so here's another video link that you can check out. And here's just kind of a comparison of energies. This isn't something that I would expect you to memorize for a test, right? But down here, way small number, kinetic energy of an oxygen molecule, little, versus the amount of energy you need to heat the entire volume of water on Earth, 1 degree Celsius, just one little degree, 10 to the 24th joules. That's really hot. Whereas a battery, here somewhere in the middle, about 1,000 joules. Energy required to lift an apple, about 1 joule. So just keeping it in reference here. And not all fuels are equal. And that's something that is important for us to understand as chemists. What you use as the fuel will get you different results. And I think anybody who's ever built a fire would have personal knowledge of this, right? If you're building a fire and you're using a roll of toilet paper versus you're using some kindling versus you're using a big giant log, right? Even just 3 different types of paper, or 3 different types of wood, I should say, will give you different results. And the same is true for other fuels: methane, octane, coal, ethanol, and wood. They're all going to be different. And something that when you're talking about a power plant is called the efficiency, how much of that energy actually makes it from the fuel to usable energy. We call that plant efficiency. And these are all types of power plants that we're going to talk about in chapter 7 in the next lecture. So in the United States, wood was the primary source of energy until the 1960s, and then coal became our biggest source. And so most of the coal that we use in the United States now is for electricity. Most people don't use coal to heat their homes anymore. And then coal shifting in the 50s. This is just kind of a little bit of a history lesson. You can read about this. This is an interactive page about how much energy gets used. It's really interesting for you to go check out. And then here is energy consumption, and notice the unit, quadrillion kilojoules. Yes, there really is such a unit. Okay, so this is a lot of energy, a lot of energy. So which one is getting used for energy the most? So here's 2015 when this graph was made. Petroleum was number 1, and then natural gas, and then coal, and then renewable energy, and then nuclear is this blue one. So oil is not just hanging out in a pool underground. It's actually within little pockets of rock and in their formations. And so oil is extracted and you force it out. And so you've probably heard this word in the news: fracking, to get natural gas or petroleum from other sources way down deep. And a lot of people really love it, and a lot of people really hate it. So it's a topic that you probably shouldn't bring up at Thanksgiving dinner unless you want to have a fight, because there are a lot of people with strong opinions on both sides. So most of oil that we use is for transportation and heating here in our country. And so if you've ever heard of octane ratings, octane refers to the breakdown in your fuel. That's not something you would need to know on an exam, just for your knowledge. And here's another link for you to check out on your own about chemistry. Biodiesel is generated from fats and oils, such as cooking oil that you have no more use for. And so this is, again, not something that you would need to know on a test about how many double bonds and that sort of thing, but it gets thrown around in the news a lot. And so I want you to at least be aware of what it is, so that when you hear about it, you're not just completely going, I don't know what that is. And so here's you can see some of these molecules. Renewable energy is energy, as the name implies, that can be renewed. So fossil fuels are obviously not considered renewable, because once the fossil is gone, then it's gone. Nuclear power, then we've got, that's also not considered renewable, by the way, because once you have the nuclear reaction, it's done. You've just got nuclear waste at that point. And then the remainder is the renewables, and break that down: your biomass, geothermal, solar, hydropower, wind, solar, biomass, geothermal, biofuels. So these are all the topic of chapter 7. So that's where we're going to stop for chapter 6. And if you have any questions, please feel free to reach out to me. Otherwise, I hope you have a great day, and I will see you next time. Bye.